The story of the VoltPRO. Hi, today I'm going to present you a product that we developed a few years ago, already thinking of the crisis of power failures and ESCOM switching us off and on, which normally is cause of overvoltage. The idea was to create a little device, and this is the final product, that is going to protect us from overvoltage that can damage our electronic or electrical equipment. So let's start from the physical size, which are very small. That means it can fit inside a light fittings, street lighting, or perhaps into a special plug, and like this one, where the unit fit is inside, and that's what allows you to plug your appliances. What this unit can do: in case of load shedding, the critical moment is when ESCOM will reactivate, energize the suburban, that circuit that you're on. At that point, it has a very strong possibility of overvoltage. That's because as the system's trying to stabilize and delivering perhaps the 230 volts perhaps. But in doing so, that you could have a big fluctuations. That is what we call a temporary overvoltage. Normally not that dangerous, but could cause some small damage that eventually become permanent. But the most insidious one is a permanent overvoltage, where perhaps a neutral gets stolen, and we have lots of this today, or a substation is not regulated properly, and now you got a voltage coming to your home or to your establishment that is perhaps 250, 260, 280, 300 volts. First things that happen with the moment the power is back is that this will hold back, for better words, to energize your system for about 7 seconds. And during that 7 seconds, the unit will monitor, and it will only allow voltage to come through if that is within the parameters, okay, which is not greater than 265 volts, give or take. And in case, if that's everything okay, the power will be reestablished. If during normal functioning, what the other things it can do is that will keep monitoring and disconnect you within a maximum of 2 seconds for small variation of voltage above the 265, which we call as a tiny overvoltage, in order to eliminate constant nuisance. So we decided to introduce a delay of a maximum 2 seconds, but that's only for a tiny overvoltage. So you mean that what we're saying is, like, we're hoping that the problem to resolve itself. If it doesn't, the unit will trip. If for higher overvoltage, for 280, 300 volts, the unit will intervene within like about 90 milliseconds. Okay, the electrical characteristic: the unit can handle 10 amps. The unit can handle 100 amps of inrush current. And most important, the unit is rated 400 volts, been made to live on a overvoltage environment. So your neutral gets stolen and this unit get 380, 400 volts. That's fine. That's what it's being rated to operate. So no damage will incur on the unit. Furthermore, the unit can also withstand surge of up to 10,000 volts. We estimate a number of 15 times, although it's not a surge protector. For that, you need to use a separate device. I'll give you a practical demonstration how the unit performs. The unit has got 4 wires, a common neutral, so you basically got a live in neutral in and live in neutral out. If the unit functions properly, the light is green. If the unit is subjected to a overvoltage, the light will turn red, and it will stay red until you reset it. And to reset it, you have to power down for at least 4 or 5 seconds and power up. Why do we don't want automatic reset? Well, to us, that's also being a choice. It's because we want you to know you're being subjected to another voltage. Sometime for a temporary overvoltage, transient, well, that's okay, can happen. But if it's a permanent that happens, for instance, every night, we don't want the unit to reset themselves automatically. You want to be able to catch this unit having gone onto overvoltage mode and then go and resolve the problem, because it's not going to get any better. Let's look how this thing works. So if I activate the unit, I first have to, I'm waiting now for the unit to check if the voltage is okay. The voltage is okay. The green light is on. 250 volts. So what happens if voltage increases and I'm going to creep slowly. I'm at 264. I know I'm on the limit, and within the next small movement, there we go. There are 273 volts. Power is not coming back. Even if it now is back to 240 volts, as explained, the system is not an automatic. The reset has to be by power down or by disconnect the circuit. That's represented what it could be a circuit breaker or a switch. For 4 or 5 seconds, the system is now querying and checking if the voltage is okay, and it's okay. So let's see now, we're going to go another example where I'm going to go to, there we go, 270, 300 volts. Great. Now I'm going to reset. The red light is off. It's only because I took power off the system. The moment I let go, it will verify if the voltage is okay, and it's not. So the red light came back. So it's a pretty simple system. In other words, this will reconnect you to the main only and when after the reset and the power, the voltage is back within the parameter. 263 volts should just make it. Let's see if it's answering. That's it. As I'm touching this 265 absolute limit, I'm gonna just now I'm gonna show you now about the 2-second delay. So let's go down. We're gonna reset. This is it's a feature we added to the device to eliminate, or should we call it false alarm? Should we call it, the transient, which are not sufficient to damage your circuit. Pay attention to the yellow light. You'll see that they brought it up and come back. In other words, we being on a transient, and we have just come back quick enough before the system clip. But if I go further up, like I did now, it will 90 millisecond and it will cut me off, which it just did. That will protect your system. There's other idea, an application for the unit is take this unit, activate a contactor, control the coil of a contactor, and now whatever is connected to that contactor is protected. It's a small and economical voltage over voltage control regulation. Thank you for listening.